We will begin this module by explaining the basic concept of the fly-by-wire system.
In conventional aircraft, the movement of the control column is transferred along cables and pulleys until it reaches the control surface to be moved. In the A330 A340 family, the cables and pulleys have been replaced by electrical wires. This has the advantage of saving weight on the aircraft. However, there are even greater advantages, as the video clip will demonstrate. Click on the video window to start it.
Now the way became clear to reassess the mechanical linkages, transferring the control commands to the electrically actuated hydraulic motors that work the flying surfaces. As electrical signals were already being used to control the motors, the logical step now was to send the message to them direct from the control column by electrical wire, resulting in a far simpler and lighter system. And without the need to exert muscle power, the conventional control yokes could be replaced by small side sticks.
The electrical signals, created by side stick movement, travel through flight control computers before being transmitted to the surface hydraulic actuators, also named servo controls. These computers analyze the signal to check that it is a safe command and ensure the optimum flight control surface deflection for the demand.
This has advantages over conventional systems. It makes the aircraft extremely stable, enhances safety, reduces the workload of the pilot. Let's now look at the flight control surfaces themselves.
The flight control system includes ailerons, elevators, a trimmable horizontal stabilizer, THS, for pitch trim, a rudder, ground spoilers, speed brakes.
Now let's introduce the ECAM flight control page. You can see that all the flight control surfaces we have talked about are displayed. We will now see them in more detail. The movements of both ailerons and both elevators are symbolized by a green index moving in front of a white scale. The green rudder symbol is used as an index to display the movements of the rudder on a white scale. The rudder trim is indicated by a small blue line below the scale.
Note that the rudder and the pedal deflections are limited as a function of speed via a rudder travel limiter. The high-speed position is indicated by small green lines on the rudder scale.
The pitch trim position is indicated by trimmable horizontal stabilizer deflection in degrees up or down. Let's continue with the spoilers.
The spoilers have several functions. Speed brakes use all the spoilers. Roll control uses the 5 outer surfaces. On the video, look at the left spoilers as they deploy, then at the right ones as the wings are leveled. Click on the video window to start it.
Ground spoilers use all surfaces. On the video, watch as all the spoilers deploy at touchdown. Click on the video window to start it.
On the ECAM flight controls page, the spoiler extended position is indicated by small arrows. This is the case of the speed brakes. Now, we will look at the flight control computers. The movements of the flight control surfaces are managed by 5 computers. These are 3 primary computers, PRIM, and 2 secondary computers, SEC. In addition, 2 flight control data concentrator computers, FCDC, are used to acquire data from the PRIM and SEC. Then, they send it to the EIS. The status of PRIM and SEC is indicated on the ECAM flight controls page. The other computers are not displayed. Now, we will see the hydraulic aspect.
Three independent hydraulic systems are used to power all the flight control surfaces. The hydraulic systems which actuate each control surface are indicated on the ECAM flight control page by the use of G, B and Y. For example, the rudder is powered by the green, blue and yellow hydraulic systems. The ECAM flight control page is now complete. Pilots control pitch and roll through 2 side sticks.
There are related side stick priority lights. Side sticks and priority lights will be explained in a separate module.
Pitch trim wheels are located on the center pedestal. There are 2 sets of conventional rudder pedals. A rudder trim panel is located on the pedestal. A speed brake lever is located on the left side of the pedestal. In addition, there are two panels located on the overhead panel to control the flight control computers. Now we will introduce the lift augmentation devices.
There are 7 slats on each leading edge.
And 2 flaps on each trailing edge. The slats and flaps are hydraulically actuated like all the other surfaces. They are electrically controlled via 2 slat flap control computers, SFCC.
Each SFCC has 2 channels, one for the flaps and one for the slats. Each channel can drive its associated surfaces.
The flap lever located on the right side of the pedestal operates the slats and flaps. The flap lever has the following positions: 0, 1, 2, 3 and 4. The flaps and slats information is shown on the engine warning display. The flap and slat positions are indicated by white dots. Here the surfaces are extended to position 1 plus F.
This is the flap 0 indication. The slats and flaps have protection functions. In particular, surface asymmetry between left and right wing, surface attachment failure, overspeed or uncommanded movement are detected. All these protections will be studied later. Let's review some operational indications. The pitch trim values related to the takeoff CG values are indicated on the scales beside the trim wheels. After engines start, when the 3 hydraulic systems are available, the takeoff trim is automatically set, calculated by the prime, according to the 0 fuel weight CG entered in the MCDU, and the fuel distribution. The takeoff trim setting must remain in the takeoff green band range. Note, on the A340, the takeoff trim is manually set according to the CG. The pitch trim position set may be seen on the ACAM flight control page during the flight control check when taxiing, if required. Notice that without hydraulic pressure, the bank angle protection indicators are displayed in amber on the PFD. The side sticks are inoperative because there is no hydraulic power. Moving the side sticks will not affect the control surfaces. After first engine start, as soon as hydraulic power is available, the green bank angle protection indicators appear, indicating normal yaw. The side sticks become operable. On ground, the control surfaces respond in direct relationship to movements of the side sticks. This ground mode enables pilots to check the flight controls. Note, a rudder pedals disc button is provided on the nose wheel steering handle to prevent any unwanted steering inputs during rudder pedals test. The takeoff memo is normally checked during taxiing. For training purposes, we have displayed it now. The flaps should be set to their takeoff position, 1 plus F, 2 or 3. While the flaps are deploying, we will be looking at their indications on the engine warning display. To set the flaps, you need to lift up the lower part of the flap lever and then position it to the appropriate setting. Here, as an example, we will select flap 3. As soon as a flap selection is made, blue markers appear on the engine warning display to show the selected flap and slat positions. A blue number shows which flap position has been selected, here 3. The word flap appears in blue. The current slat position green markers move, followed by the flap. The white labels S and F appear. When the flaps and slats have reached the selected positions, all position indications turn from blue to green. The word flap changes from blue to white. The flap's takeoff memo on the engine warning display turns to green. Note: on the A340, there are only 2 slats positions versus 3 on the A330, shown here. When the flaps are extended, the ailerons are dropped by about 5 degrees in order to increase lift. The aileron indexes are now pointing to a small white square, which represents the new neutral position. Note: on the A330, there is a second aileron droop position about 10 degrees in configuration 2, 3, full. We are in flight. Flap 1 is set. Notice both slats and flaps are extended to the first position. This is 1 plus F configuration. The airspeed is increasing through S-speed, minimum speed for SLAT retraction. Flap 0 would be normally selected at this stage. To demonstrate automatic flap retraction, we will delay this action. As the speed approaches VFE at flap 1 plus F, the flaps will automatically retract fully. This auto retraction speed is higher on the A340-500/600th. Please refer to your FLICHT for the exact value. Notice the slats remain deployed in their first position. This is configuration 1. There's no automatic retraction of the slats. In all flap configurations, the speed brake lever can be moved rearwards to any position, depending on the amount of drag required.
For training purposes, we have called the ECAM wheel page for you to remind you of the indications. The indications are also shown on the ECAM flight control page.
We are back to normal display. With some power on at least one engine, the speed brake message will flash amber. We have retracted the spoilers. The spoiler retraction can be confirmed on the engine warning display by the disappearance of the speed brake memo message. We have activated the approach phase. The airspeed decreases below the maximum speed for flap extension, or VFE, shown on the speed tape by amber dashes. We can now select flap 1. Flap 1 is selected. Notice that an airborne selection from flap 0 to flap 1 deploys the slats only. You cannot select flap 1 plus F from flap 0 in the air. The speed has now decelerated to below VFE for flap 2. During landing, passing 50 feet, a slight pitch-down elevator order is applied, so that the pilot has to move the side stick rearwards to maintain a constant path. Therefore, the pilot has to perform a gentle flare, as for a conventional aircraft. Spoiler, armed. At touchdown, with the main landing gear compressed, the ground spoilers deploy automatically and operate as lift dampers if the thrust levers are at idle or reverse. Spoiler extension can be monitored by the pilot non-flying on the ECAM wheel page. On the A340 600 and 500, ailerons are also used as lift dumpers by deflecting upwards. Note: if only one main landing gear leg is compressed, all ground spoilers will extend partially, thereby decreasing the lift and compressing both main landing gear legs. Ground spoilers will then fully deploy. If a go-around is done, the ground spoilers will automatically retract when the power is spoiler boy. If a go-around is done, the ground spoilers will automatically retract when the power is applied.